Hi, I am Salar, a .NET developer, web security enthusiast. What if I told you that only knowing a small flaw of encrypting, especially AES algorithms, could help you to easily bypass an authentication system? So today we are going to do a PortSwigger laboratory, which is named as Authentication Bypass via Encryption Oracle. The main purpose of this laboratory is just bypassing an encryption system, bypassing an authentication. But there are some steps in this laboratory which are related to AES algorithm, which my main focus on that is to work on these behaviors of AES algorithms and find new things that will make us more experienced, maybe. So I will not explain more than that. I will have been using a tool named Burp Suite, which is a tool made by this company PortSwigger. And I have opened the laboratory here on the uh, Burp Suite proxy tab. I have opened it and I have got a username and a password, which is given to me by the website Wiener Peter. I go to the website, I go to the home page first. I go to the my account and I paste Wiener here and I have the password Peter, and there's a checkpoint here named that stay logged in. I will check this too, and then I just log into the page and we see that we have logged in now. I click on home and there is a blank page here. I will just choose one of these blog posts here. I view this post, I go down to the comment section. There are some steps which are mentioned on the PortSwigger laboratory solution and explanations, but I'm going to skip some extra steps that won't help us at all. So I just now add a comment here. I give it a name, I give it an email address, but in the email address I'm just going to delete this @sign and make it as an invalid email, and I just post the comment. When I post the comment, I get an error message, invalid email address, sorry, no mail. So from now on, what I'm going to do is just going to Burp Suite. I scroll down. I will see a request here with the post method, and then I request with the get method. I right click on it. I send it to the repeater. These are related to posting the comment. I choose this one also and send it to the repeater. Now I've got two requests here, two APIs here. One is a post method and the other one is a get method. So there are also some cookies here, like the stay logged in cookie. And also on the get one, we have a notification cookie, which if I send it to the server, I will get a message here, invalid email address that we earlier saw on the browser. So, and also the post method, if I send it, I will receive a cookie named notification and an encrypted phrase here. Let us play a little with this. I will copy this, go to the get, and I paste it in the notification. This is what we had earlier, and we can see that it is getting decrypted. But we have got also something else here as the stay logged in cookie. I can copy this maybe and paste it in the notification again and send it to the server. And I scroll down and I will get this. This is what is called in encryption oracle. We can encrypt and decrypt and whatever we like. So the purpose here is to bypass the authentication. It seems that there is a cookie here named as stay logged in, and it seems that the authentication is strongly based on this cookie, stay logged in. And when we decrypt it, we get this winner, semicolon, and a timestamp. But before everything we do, we should know that this post method is actually working as an encryptor. So I call this as encryptor. This get method also is working as a decryptor. Okay.
So we have just renamed them. And now what I'm going to do is that I will try to make another stay logged in cookie encrypted in encrypted format, that when we decrypt it we get something like administrator semicolon and a timestamp, and then we are going to use it in the stay logged in cookie and see that what will happen. So what I'm going to do is just copy this timestamp, and I go to the encryptor and I scroll down, and the email part, which is solinovel.com, which was invalid email, I just type administrator semicolon with timestamp, and then I send it, and I will receive this, and I copy this. I go to the decryptor. You see, we have decryptor and encryptor in the same place. And the notification part, I will again paste this new encrypted text. This is 200, everything is okay. And what I get is this. I have been kind of successful to create administrator semicolon and timestamp, but there is an extra part here, invalid email address semicolon and a space, which I don't need it. If I count the number of characters, that will be 23 bytes. So what I have to do is to delete these 23 bytes from the start of the encrypted phrase and use it as I want. So I will just select this notification that we made until now, and I send it to decoder. I go to decoder tab. I see some percent signs here, so I will just decide to decode it as URL. Maybe it seems good. At the end, I have some equal signs, so I decide to decode it as base64. I will decode it as base64. And what I've got here are some bytes. Every row here contains 16 bytes. So now this is the time to explain what's going on. AES is an advanced encrypting system which only works with 16-byte blocks of data. When I try to encrypt the data by AES, AES tries to make it as a 16-byte block data. For example, if I send a 5-byte data to the encryptor, then it will add 11 extra bytes to it as paddings to make it as a 16-byte block data. So whenever it goes to get decrypted, the decryptor can confirm that this is 16-byte block data, and also the padding is also added by the valid encryptor of AES. So the result is that whenever you encrypt anything by AES, it must become a data which is a multiple of 16 bytes, which is made by 16-byte blocks. So all the data here are not just the data that we have passed. Some of them might be or must be the padded data. Okay, so if I go back to the repeater, I will see that I had 23 extra bytes. I go back to the decoder and I just decide to delete the first 23 bytes from here. Every row has 16 bytes. This will be 17, 18, 19, 20, 21, 22, and 23. I will delete this part, and then I will encode it as base64 again and encode it as URL again, and I will get this. It is clear that we are doing it wrong, because at the end, as you can see in this yellow part here, what has remained to us is not a multiple of 16. We have two 16 bytes here, yes, but the last row contains only about 8 bytes, and the overall of these bytes won't be a multiple of 16. So anyway, we just copy this, we go to the repeater, we paste it here on the decryptor API, and we send it, and we get a 500 error, and we go down, we see that it's saying input length must be a multiple of 16 and decrypting with padded cipher. So what happened is that we illegally deleted some bytes from the first part of this string, which made the final result not to be a multiple of 16. If we look closer, if we get wiser here, maybe we can see that whenever we have a data which is made of 16 byte blocks, If we choose one block and then in that one block, for example, we delete 1 or 3 bytes, then what remains at the end in overall manner won't be a multiple of 16, of course. But if we have the data which is which has gone to the encryptor of AES and has came back to us as a multiple of 16 bytes blocks, for example, we have 3 blocks of 16 bytes. If we delete 1 block of 16 bytes, what remains is 2 blocks of 16 bytes. So if we can make force ourselves to delete a multiple of 16 bytes, then what remains must be a multiple of 16 bytes. What we did earlier was deleting only 23 bytes, which was not a multiple of 16. So maybe we can add some other paddings by ourselves to make it to make the deleted part as a multiple of 16. We had 23 extra bytes here, but what if we can add 9 other bytes? 1, 2, 3, 4, 6, 7, 8, 9, and then send it to get the encrypted phrase. And I copy this, go to the decryptor, I paste it here, I send a request, and as the result I will see this. So now what we are going to do is that we are going to delete the first 23 bytes and also these 9 bytes here, which 9 plus 23 will be 32, and 32 is a multiple of 16. So this should be the right path. What I'm going to do is to select this made up encoded phrase and send it to the decoder again. The decoder, I will decode it as URL again, decode it as base64 again, and this time what is going on? This time we are going to delete 2 16 bytes or 32 bytes, which 32 is a multiple of 16 because we had 23 extra bytes and then we added another 9 bytes and plus of them will be 32. So I am going to delete the first 32 bytes, and what remains, of course, it is a multiple of 16. So I encode it as base 64 again and encode it as URL again and copy this. I go back to the repeater tab and in the decryptor I will paste it to see what's happening now. I scroll down and I see this. I have successfully made a state logged in cookie. I have the encoded version of that, which is here, which I can copy this, and then I can go to the proxy, I can go to the intercept tab, and I can turn on the intercept. I go to the site, I click on home, I come back to the burp suite, I get this get request, I will get rid of this session cookie, and I will clean the value in the state logged in, and I paste my own made up encoded word, and I forward it, and I turn off the intercept. I go back to the website and wait for the result to appear right now. I go back here and I turn it on. I go to the repeater again to check it out. I send it. I get sure that it gives me no, it's wrong. I have a problem here. Administrator 1, 2, 3, 4, 5, 6, 7, 8. Oops, one was missed. I will send it again. I should do it again. I added 8 bytes instead of 9 bytes. I copy this. I go to the decoder tab. I stay there. I copy this. I go to the decryptor. I change it to this. Send it again to check it if it's right. Yes, now it's right. We have 9 bytes here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and we have administrator. So this must be the right one. I select it again. I send it to the decoder. Sorry for that. And I will decode it as URL again, decode it as a B64. I delete the first 32 bytes here. And I encode it as base 64 again, and I encode it as URL again, and I use this now. I go to the proxy, I go to the Turn it on. Okay, I am going to use my made up encoded string. I get this here. I delete this session cookie. Delete the value of state like bin. Let's do it again. What I'm going to do is just to change the value of stay like in. Of course I can do that. Okay, so again, I will delete this session cookie and I will also delete the value of state login cookie and paste my made up string here. And as you see, I can now see the admin panel. So what happened was that we successfully changed the state login value, state login cookie value into what we could create by knowing the behavior of AES. And then we changed it, and now we have access to the admin panel. I can go to the admin panel and I can do whatever I want that I'm not supposed to do, but I can delete Carlos and I can see that the laboratory is solved. So it is really important even to know a very small flaw of some encrypting systems like AES, like knowing that it only works with 16 byte blocks and knowing the rules. If you know the rules, you can bypass them. Thank you so much for watching this video. I will be happy if you like it or leave me a comment or send it to your friends or someone who you believe like this video. Have a really good day. Thank you.